Alright, today we're going to talk about a special type of parallelogram called a rectangle. And you guys are all probably familiar with the rectangles already, but let's talk about some of the properties that make a rectangle special. So first, the diagonals in a rectangle. So if a parallelogram is a rectangle, then its diagonals are going to be congruent to each other, okay? Another thing we learned last section is that diagonals in a parallelogram also are going to bisect each other. So keep that in mind. Okay, so diagonals bisect each other for every parallelogram, but specifically a rectangle, the diagonals are also congruent to each other. So this diagonal, if this is a rectangle, is going to be congruent to this diagonal in a rectangle. Okay. And that's pretty much it, other than the diagonals being congruent. Other things that are special about a rectangle is that it's going to have 4 right angles here. Okay, so we know that right angles mean that they are going to be 90 degrees. Okay, so let's jump into examples. So we have a rectangle garden gate is being reinforced with diagonal braces to prevent it from sagging. If JK, so JK is up here, is 12 feet, and LN, which is here, is 6.5 feet, find KM. KM is this whole thing. So we have a few things going on. One of these is irrelevant. Okay, so we're looking for KM, the diagonal. This outside number, the 12 feet, is not really going to help us out on that one. But I did just learn that diagonals in a rectangle are congruent. So that means that if I were to extend this green line, that green line is going to equal my other diagonal, the orange line, okay? So I do know that this green line, this is 6.5. And remember that diagonals bisect each other, which means the other half is also going to be 6.5. So 6.5 and 6.5 equal 13. Well, if this whole diagonal is 13, that means the orange diagonal is also 13. So KM is actually 13 as well. And we're talking about feet, so that would be my answer. Okay, so just a few properties to keep in mind as you're solving these rectangles. Then the next one we have is EFGH is a rectangle if GH is 6 feet. So this is 6. FH is 15. And now I'm looking for GJ. So this right here. That was bad placement for the 15. Okay, so we're looking for this. So this one's kind of the opposite, right? I know this measurement, this was 15, and now I'm just looking for half of the other diagonal. So I have 15 divided by 2, because I know they bisect each other when they intersect. That gives me 7.5. And this is going to be true for GJ. So this is also going to be 7.5 feet. Okay. And this set of notes is super short. Here's the last example that we're going to do. So we have a quadrilateral with those vertices, and it's already graphed for us here. We're going to determine if this is a rectangle using the distance formula. So in the last set of notes for 6.2, we talked about different tests that we could do to see if it was a parallelogram or not. We looked at the slope. We looked at the distance formula would help us too. So this is specifically telling us to use the distance formula, and we're trying to see if the opposite sides of these of this parallelogram are congruent, so that way I can assume it's going to be a rectangle or not. Okay, so first I'm going to start off with reminding you what is the distance formula, and the distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so we're taking our x's and finding the difference. squaring it and adding it to the y's difference and squared, okay? So here we go. We're going to start off with JK. So finding the distance of JK, again, you are going to assign to the J and the K, like this is going to be your x1, y1, and this is your x2, y2, and then we're just going to put it right into the formula. This is great practice for those tests. Oh, sorry. 1 minus that -2 squared plus 4 minus 3 squared. And again, I am just following this formula. I'm substituting in those numbers. And what's nice about this one is we can actually enter everything inside the radical into my calculator and then leave the radical alone, okay? So when I enter all of that in the calculator, my calculator should give me 10. And I'm going to do that again, and I'm going to do that with M and L. That's the next set of the segment that I'm going to compare. So this is going to be my x1, y1. This is my x2, y2. And same thing, I'm substituting into that distance formula by following. So I have 3 minus 0 squared plus -2 minus -3. It's important that you're careful with those double negatives and that you're entering them in the calculator separately. One's a minus, one's a negative. If you put it in the wrong thing, your calculator might get mad at you. Okay, when I enter that in the calculator, that also gives me the square root of 10. So these two are congruent. Okay, so that's helping me out so far. So far I have one pair of congruent sides. Now I have to compare the other two sides. And to do that, I'm going to start off by comparing JM. So I'm going to find the distance of JM now. Again, go back and label these x1, y1, x2, y2, and then substitute into your formula. So 0 minus -2 squared plus -3 minus 3 squared. Again, we're going to enter everything inside the radical, not the radical in our calculator, just what's inside. And then we're going to leave the radical alone there. That gives me 40. Okay, so I'm going to see how that compares to my other side. So right now I'm comparing, again, I just did JM. Now I'm going to compare that to KL. And this is x1, y1, x2, y2. Finding the distance of KL. And I do 3 minus 1 squared plus -2 minus 4 squared. And this, when I enter it in the calculator, also gives me square root of 40. So now I have another pair of congruent sides. Okay, so because it's only asking me to find the distance formula, then I can assume yes. One step further to make sure for sure these are rectangles. Something that we talked about at the very beginning is that rectangles also have a 90-degree angle. That's what makes them special. And in order for me to create 90-degree angles in my picture, I need opposite reciprocal slopes. Opposite reciprocal slopes. Okay, so if I were to compare this slope here has rise 1 over 3, so it has a positive 1/3 slope. Same thing here, 1/3. And then when I compare this slope, the rise is down 2, 3, 4, 5, 6 over 1, 2. So -6 over 2 is actually -3 over 1. So when you look at positive 1/3 and -3 over 1, these slopes have the opposite signs. One's positive, one's negative. And the reciprocal means that the fraction is flipped around. So one says 1 over 3, where the other one says 3 over 1. When this is the case, I know that these two lines are creating those 90-degree angles. And that's going to be the case all around. That's why this is a rectangle. So we're checking for both that the slopes are opposite signs and reciprocals of each other. And we're also checking that the opposite sides are congruent. And we have 2 of those pairs. Okay? And that's the end of these notes. So that's what makes rectangles special, that it has both 90 degrees, opposite sides are congruent, and the diagonals are also congruent to each other.